For thousands of years, the Young Husband Peninsula has protected the Coorong Lagoon from the Southern Ocean. Less than 4 hours' drive south of Adelaide, this long, windswept peninsula is a wilderness area of great scientific and aesthetic value. It has now been declared a national park, the first step in a long-term plan to conserve it.
The Young Husband Peninsula is a barrier system stretching from the Murray mouth just behind me southwards for about 150 kilometres towards the Victorian border. It is the subject of a long-term ecological survey by the South Australian Museum. The survey's purpose is to find out the relationships between the plants and the animals that live here and their environment.
About 18,000 years ago, glaciers that covered much of the Earth's surface began to melt, gradually causing the sea level here to rise about 120 meters. Before it stabilized at its present level, some 5,000 years ago, the sea carried millions of tons of shell grit and sand over the continental shelf, finally piling it up into the coastal barrier system that we now call the Young Husband Peninsula. The shape of its ocean shore is altered each day by the changes of wind and tide. And there's an overriding seasonal change, too. The shore is built up in summer, eroded in winter. And cast up with the shell grit and sand are cuttlefish bones and shells, seaweeds, and jettisoned timber. The Posidonia ball reflects the harmony between the beach slope and the surf. The balls are formed from the fibers of decaying Posidonia weed, and they grow in size as they're rolled by the surf along the ocean floor to the beach. They're just one of the intriguing aspects of this barrier system. There are many others.
This layer of calci has been eroded by storm wave action. It was probably formed by rainwater leaching down through ancient dunes and bringing with it carbon to form this rock-hard layer. We believe it was laid down about 80,000 years ago when the sea was back at about present level. It underlies the whole of Young Husband Peninsula, forms a basement on which these present dunes have formed over about the last 5,000 years.
The foredune, or berm, is the next stage of the dune system. It runs the entire length of the barrier, acting as a buffer between the sea and the higher dunes behind it. Only the hardiest plants can survive in this zone. The most common of the first plants to establish themselves here is the native coastal spinifex. It grows rapidly with long runners and a complex root system, so it's well adapted to stabilizing the mobile sand. Then there are other plants that came later, the secondary colonizers, like the common reed Scirpus nodosa. They add decaying plant material to the once sterile sand, so beginning the formation of soil. Clumps of the native festuca grass stand in contrast with this U-form, which has been introduced only recently. The effects of these exotic plants must be carefully monitored, for they tend to overrun the native vegetation. From time to time, huge storm waves cut through the foredune, carrying flotsam and jetsam to the hollows behind it. These are called swales, and the timber strewn around them provides a new habitat for the animals that once used to live in the dunes themselves. This small sand dragon has adapted well to the artificial habitat. Normally it burrows in the dunes. Now, under planks and logs, it finds the right conditions of temperature and humidity and is well protected from the harsh environment. Its sand-colored back helps protect it from predators as it moves about at night, feeding on small insects and sandhoppers. In the fore-dune and swale zone, we find not only the beginnings of soil formation, but the beginnings of plant and animal communities as well. The centipede is another adaptation to this new habitat. Ants play an important role in this system by recycling dead insects. When they're disturbed, their first reaction is to take their eggs to safety underground. A pair of sand dragons. They've mated and built a nest, lining it with the dry husks of spinifex seeds. This whistling kite is just one of the birds of prey on the barrier system. Birds that are the final link here in a food chain that begins with plants and runs through plant-eating insects, carnivorous insects, to reptiles and marsupials. Millions of cockle shells, gathered in the past by Aborigines, are now strewn over the swale areas. On the larger hind dune, secondary and tertiary colonizers like coastal wattles, Olaria and leucopogons are exposed to harsh environmental extremes, salt spray, wind pruning and sand blasting. These cockles were once piled high as kitchen middens by the Aborigines. Now they've been deflated and scattered by the wind.
This arrangement of stones is just one of many of the ancient Aboriginal campfires on the Midden. The stones were probably collected from the beach face, along with the cockle which formed the Aboriginals' staple diet. On the fires, they cooked perhaps wombat, wallaby and other game which were once common here. Associated with the campfires and the middens are stone artefacts, tools like this one, which were once used in daily life to perhaps fashion the point of a spear, or this end to break the muscle of the cockle to make it easier to open. Middens like this obviously had great significance to the Aboriginals, for they often buried their dead in them.
In this burial ground, the processes of time have revealed only skeletal remains. The impact of the Aborigines on this environment is an important part of the present ecological study. The dominant winds here are from the north and the south. Both have been equally important in shaping the barrier and determining the ever-changing nature of its ecosystem. Wind has exposed the roots of these Olaria bushes. Perhaps within a few weeks it'll recover them, or the erosion may continue. The breach in the foredune caused by storm waves is often enlarged by wind funneling through the gap. This huge parabolic blowout is the result of many years of wind erosion.
It's eroded finally down to the layer of calce I'm standing on. The same layer we saw earlier exposed on the beach. And behind me, the truncated dune exposes a series of buried soils. The topmost is the present level of vegetation. Beneath it is an exposure perhaps 1,000 years old. And lower still is the earliest system in the barrier, a soil perhaps 4,000 years old.
The dunes consist mainly of shell grit, calcium carbonate. Over the years, soil moisture cements the grit around the root systems of plants, forming hard, resistant casts. When the plant dies, the erosion of the wind leaves these hollow casts standing in weird shapes up to 1 meter high. These fossil roots hold valuable clues to past levels of vegetation and will help to build up a picture of old land surfaces. In other areas of barren sand, the winds have carved miniature Sahara deserts and sculptured enormous transverse dunes over 50 meters high. These dune ridges extend from the ocean side of the Young Husband Barrier to the Coorong edge. We know from early air photographs that this vast dune has been in a state of dynamic equilibrium for 20 years. Through that time, the wind has been putting in and taking out sand at equal rates. Eventually, this dune may become stable and plants will begin to colonize it as they have on nearby dunes, and so another cycle will begin. The Coorong side of the barrier is protected from the harsh extremes of sand blasting, salt spray and wind, so plant and animal life here are more diverse. Old blowout areas have been stabilized by plants such as coastal wattles, olerias and myoporums. Introduced species can easily upset the delicate balance between plant and animal life. These land snails have almost completely defoliated this native oleria bush, and in other areas, other plants have suffered. The scientists hope to find biological controls for this pest, for in natural communities, pesticides have a disastrous effect on the native animals. Among the snails and pig-face plants, a harmless shingleback skink suns itself. Its tail looks like the head to confuse predators, and its armor-like shingles are further protection. Although it's too big to be worried by this immature black-shouldered kite, it still seeks the camouflage of dead vegetation. This young black-shouldered kite has not yet molted to the grey and white colouring of the adult bird. Its large eyes and powerful talons are ideal for catching prey. Like this common house mouse,